Hi, this is Chad Houston. This is just a quick little tutorial on the introduction of moles. And there's a wonderful Bozeman science video that I've sent to Mrs. Z. It's on Chemcast. To type in Bozeman science, Bozeman, B-O-Z-E-M-A-N, the mole, Bozeman science mole. It's fantastic. He does a great job. This is to supplement that, to just give you a little bit of extra practice. So first of all, why the mole? Number one, I would definitely write this down. It's just a really, really big number used in chemistry. Just like a dozen means 12, just like a ream of paper is 500, just like a decade means like 10 years, or century means 100. We have words to describe large numbers. In this case, the mole is a word. It's Italian for mole, or mountain, which is a mountain of stuff. And it means 6.022 times 10 to the 23rd of anything. So for instance, if I had a mole of red hot candies, for instance, that would be large enough to fill the earth 3 feet deep, including the oceans, of red hots. So why this huge number? Well, we use this huge number because atoms are so incredibly small. And it takes tons of them, like a mole, just to make a few grams sometimes. So just like a dozen means 12, a dozen large eggs has a mass of 24 ounces. Well, it turns out for a mole of any element is the atomic mass of that element, and it's found on the periodic table. So definitely write this down. But carbon, for instance, if I needed a mole of carbon, or an exact number of carbon atoms, like 6.02 times 10 to the 23rd, or half that, 3.01 times 10 to the 23rd, I could just go to the periodic table, find the atomic mass, which is 12, and if I pour out 12 grams, I'm actually getting a mole of carbon, or 6.02 times 10 to the 23rd atoms of carbon. Here's the really cool part about that. It works for any of those elements. Okay? So that is the cool part, and therefore, instead of taking billions and billions of years to count things, we just dump it on a scale, and presto, there we have it. That's why a periodic table is a chemist's best friend. Okay, so as you can probably tell, I get kind of excited about this. So number two, I'd like you to write this down. Okay, let's see. So this is pretty much all that you need to know. And what we have here is, if you're given any mass of anything and you need to convert to moles, we use the molar mass as found on the periodic table to get to moles, or moles to mass, same thing. You have to look on the periodic table. If, on the other hand, we're looking for the number of particles, atoms, formula units, compounds, molecules, bagels, red hots, any of those, and we have mole, then we use the number 6.02 times 10 to the 23rd particles to equal 1 mole. And then finally, and we'll get to this later, but for gases, it turns out any gas at standard temperature and pressure is 1 mole of that is the volume of 22.4 liters. That we'll get to later. This bottom part is what we will be most concerned with for now. So at this point, stop this video, write this down. Okay, so let's say you happen to be Matt Damon and you're stuck on Mars. And you're like, hey, I just happen to have so many grams of water, and I need to figure out to put it in I need hydrogen, and I'm going to use the hydrogen as fuel to get back to Earth. By the way, The Martian is one of my favorite all-time movies and books of all time. So let's say that he finds out he's got, let's say, I'm going to make up some number. Let's say he's got 145 grams of water that he can go ahead and convert. Okay, so H2O. So the first thing he wants to do is to get this to moles. And what we're trying to do is he wants to figure out the actual molecules of H2O. So we're at mass here. Okay, first we're going to go to moles. Okay, and then once we're at moles, we want to figure out the actual number of particles or molecules of water. We'll go there. So then down on this side, I'm just going to write molecules of H2O. So let's see if we can do this. Okay, so here we go. So dimensional analysis, if you haven't done it by now, this is going to seem like a foreign language. So if I have grams on top over here, I want to put grams on bottom over here of H2O. And then if I look up here, I need the molar mass. Now, it turns out there's the molar mass. I find it on the periodic table. Hydrogen is about 1 gram for every 1 mole. Oxygen right here is about 16 grams for every 1 mole. If I take 2 hydrogens, which is 2 grams, and that oxygen, which is 16 grams, I get about 18.01 gram for every mole. But before I put in numbers, I'm just going to put in the units. So notice I have units and labels on everything. We're kind of OCD about that. So if I just cancel this out, one of the things you'll find, cancel, cancel. Now I'm left with moles of H2O. So let's go over here. And again, now that we're at moles, and I have moles, I'm trying to get to like numbers of molecules. I got to use Avogadro's number. Okay. So now, same thing, factor label. Here, what I'm going to do is to say, okay, I'm just going to use the labels moles of H2O. And then I'm going to do particles of H2O or molecules of H2O. Okay, molecules of H2O. Hard to write on this board. Thank you for being patient. Appreciate it. Okay, so now moles of water cancels out with moles of water. I'm left with molecules of water. That's what's in my answer. So let's see what would actually happen here if we start putting in numbers. Like I said before, every time you go from moles to grams or grams to moles, you have to go to the periodic table. If I take 1 oxygen and 2 hydrogens, the atomic mass of those, and add those up, it's going to be 18.01 grams for every 1 mole. Now, over here, every time it says molecules or particles to moles and vice versa, you have to use Avogadro's number. Always, always, always. Avogadro. Amadeus Avogadro. Pretty cool guy. 6.02 22 times 10 to the 23rd over 1 mole. Okay, so now I'm going to have to put my pen down, grab my handy-dandy calculator, and do some math. As I do this, I'll be talking to you a bit because one of the things I'm going to mention is scientific notation. So I'm going to say 145 grams divided by 18.01 equals 8.05. I'll use 3 6 figs because 3 6 figs is what I start with in 145. Now, times, and here's where this comes into play. What I do is I say 6.022, and I use the EU button, 23rd. That always tends to get you the best order of operations. And the magic number is 4.85 times 10 to the 24th. And hopefully 4.85, that should be a 5 times 10 to the 24th. Okay, this is a 5 that's kind of hard to erase. So basically this is just one problem, but there are some common themes that we'll have here that will go back and forth. Okay, a couple things you'll need to know. Number 1, dimensional analysis, factor label. No units, no labels, no credit, ever. Okay, at this point, I mean, if you go on in physics, anything else, same thing, you have to have it. Number 2, if you're going from moles to mass, mass to moles, always have to look in the periodic table for the conversion factor. If you're going from mole to particles or particles back to moles, always have to go to Avogadro's number. We'll do 6.02 times 10 to the 23rd. And finally, if you need help with scientific notation, don't forget to ask. We'll be doing a lot more problems. Thanks a lot. Have a great day. And don't forget to check out the Bozeman Science video.